Okay, so to begin our constructions for today, we're going to start with a perpendicular bisector. We did this one before, but you might be a little rusty. Notice that I have a segment to begin with. I'm going to note the end of my segment, marking it with these yellow. Please be quiet. I'm going to take my compass and I'll stick the needle on the right-hand side of my segment, the end point. And I can adjust my compass to be any measurement that is more than halfway. I got to be beyond what the midpoint would be. And then I'll make a mark. It'll be a half circle. And I'll pick up my compass, keeping it the same size, and move to the left-hand endpoint of my segment. And make another arc that's exactly the same size as my first one. It makes a football, or what I call a football. And you'll notice that the end points, the pointy parts of the football, are points of intersection. If I take my straight edge and draw a line connecting those two things happen. One, it's perpendicular. And two, it's a bisector. So it splits this segment exactly in half. There's a couple of straight edges over here. Now, as I told you, there's actually 2 pages of this in your packet. There's this first page, which is notes for us. And then there's another page. If you flip it over, it'll say perpendicular bisector. Now it's got homework. So would you please now flip this over and do it again here? This is part of your homework. Please remember to make the proper notation showing that it's perpendicular and that it's congruent. Now, this skill, perpendicular bisector, is the core of something you're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like another 30 times today. So getting good at this is something you should do. Let's flip back to the notes side. We're going to do a different skill. We're going to create a different segment called an angle bisector. But it turns out it's very much like this one. The trick is I need to find a segment that runs right down the middle of this thing. The way to do it is to take my compass, stick my needle in the vertex here, and make an arc. How big? It doesn't really matter. I just want to make sure that it goes across both sides of my angle. It has to meet here and here. Now what I'm going to do is basically turn this and treat this like the segment we just did. I'm going to make a perpendicular bisector between these 2 points. So I'm going to go more than halfway, make an arc, carry that same length to the other side, and there's my football. And if I connect these little X's to the vertex, they should go right through like that. And what that does is it bisects the angle for me. And again, move over to the homework side and do it again. First, make an arc, any size, as long as it hits both sides. Second, we're going across this gap like it's a perpendicular bisector. So I'm going more than halfway, making an arc, and then do it from the other side, the same size. When I connect those orange dots, they should be collinear with my vertex. And that allows me to mark that these angles are the same. And if you're fast with these, where you're able to get it done before I get around to checking folks, feel free to flip back onto page 1 and do some of those little algebra problems. Come around and you can have trouble. So we did a perpendicular bisector and an angle bisector, which is kind of the same thing with an extra little step. Now we're going to do a median. Do you remember what a median is from our discussion yesterday? Still on the board. What are the two features of a median? Goes through the vertex and it goes through the midpoint. So if only there was some way we could find where the midpoint of this bottom segment is. Any ideas? Yeah, Mark.
Well, I think you can find the perpendicular bisector.
If we do the perpendicular bisector, doesn't that find the midpoint for us?
Yes.
So just like we've been doing, go from these endpoints. Go more than halfway. Make your little arc. Same length from the other side. But this time, of course, we're not actually going to draw it all the way through. We don't need the whole segment. If you want, you can do a little dotted thing to show where it came from. But really, all we're looking for is that mark to say that it's the midpoint. We're not using the perpendicular nature of it. We're only using the bisector nature of it. And what the median does is it connects this endpoint up here to that midpoint. So we'll just connect those. That's our median. And once you've done one median, please flip to the homework page and do the second one. And I do think it's a good idea to show that this is the midpoint by putting in those hash marks. All right, let's go back to the notes side for altitude. What's the altitude? So based on what we've been doing here, you know it's going to involve the perpendicular bisector. Are we going to be using the perpendicular nature or the bisector nature? Perpendicular. But the problem is if I do a perpendicular bisector here, it's going to go there. It's not going to go through my vertex. So my trick is, how do I force this thing to think that my segment is like just underneath where it's supposed to be? So there's a trick. And we did this before. We called this perpendicular through a point off the line. I'm going to put my needle in the vertex here. And I'm going to open up my compass big enough that I cross over this bottom line in two places. Now you'll notice that it crosses one hard place here and it's crossing this dotted extension that I drew in for you over here. But just like we just learned with the perpendicular bisector theorem, if those lengths are the same, which we just forced them to be, then when I find that midpoint, it'll be perpendicular. So now from these two yellow points, what do? Do the perpendicular bisector. More than halfway, make my football. And then if I connect those endpoints of my football, it should allow me to produce something that is perpendicular and through that vertex. Then flip over to the homework side and do it again, please. All right, what's your confidence in producing perpendicular bisectors? 5, I can do not only those, but angle bisectors, medians, and altitudes because I get it. 3, as I look at these notes, I think I could reproduce these as necessary. It's not embedded in my head yet, but I can do it. 1, I keep poking myself, ouch. Okay, good. Now, remember last class we talked about triangle centers? Circumcenter, in-center, etc. If you flip to the back page of notes, the back side of what you were working on before, you'll notice that mine isn't stapled very well, but this is the circumcenter, this is the in-center, this is the centroid, and this is the orthocenter. Here's the trick. Do 3 perpendicular bisectors. And that'll make a circumcenter. Do 3 angle bisectors. And that'll be your in-center. Any guesses what we do to make the centroid? 3 medians. And the orthocenter. 3 altitudes. So what does that look like? I'm going to color my little corners here just for easier conversation. I'm going to start with the longest side, and I'm going to create a perpendicular bisector. So I'll turn my page so this is down for me. From the green, I'm going to go more than halfway. And then the same arc length from the yellow. That's not very good up there, but this is my perpendicular bisector. Okay, so now let's turn it to look at our next bigger side and do the same thing again. Now I'm doing it between the yellow and the orange. More than halfway. And the hardest part about this is keeping track of which arcs are which. So I'm going to do that just to show that those are those. So there's my second perpendicular bisector. And then I'll do it from this small side. What's going to be the risk in this small side? It's going to go off the paper. So when I choose the more than halfway, choose it really close to halfway, just barely more than halfway. And what that'll do is make it a really tight little football there. What do you notice about all 3 of those perpendicular bisectors?
Yeah, I'll go into 1 point.
They do. That's called a point of concurrency when they all meet at one point. And it's kind of a unique thing. It doesn't happen all the time. And that's because this is a special point. It is called the circumcenter. And what's special about it is, watch this. I'm going to take my compass and put the needle on my point of intersection. And I'm going to adjust my compass so that it goes through my green vertex. If I now draw a circle with that same radius, what do you notice?
Draw all 3 vertices.
It goes through all 3 vertices. In other words, this is the point that is equidistant from all 3 vertices. The center of a circle that goes through all 3 vertices. That's the circumcenter. Yeah. Yeah, take a bathroom pass, please. When you do the in center, it's going to be angle bisectors. And what you'll find is that it's going to be the center of a circle that just fits inside perfectly in here. And the centroid will be a balancing point. It won't be much you can do with it here. And the orthocenter doesn't have as much information on it. It's part of the 9-point circle and the Euler line, but it's not going to mean much to us. So please take the rest of the period to do another one of these in the homework, and then do the 3 angle bisectors to find the in-center. Do it on the homework. Do the 3 medians to find the centroid. Do it on the homework, etc. You've got the period.